Good morning and good afternoon, everyone. Welcome to our 2024 Summer and Tropical Weather Risk Assessment. My name is Andrea Berg, and I will be your host for today. I just want to go over a few housekeeping items. We are recording this webinar, so if you would like to listen to it again or share with any colleagues, we will be sending out a link to the recording when it's available, probably early next week. If you are experiencing any technical difficulties, you can contact me through the chat feature, and we have reserved time at the end for any questions. So please use the Q&A feature or the chat feature on the right-hand side of your screen. So with that, I'm going to turn the presentation over to Nate.
All right, thank you very much, Andrea. And welcome everybody. Thanks for joining us. And Steve and I will have a lot of information to cover, so we'll get started. First of all, let's introduce ourselves real quick. My name is Nathan Hamblin. I'm a weather risk communicator for our long range team. And Steven Strum is our fearless leader, the weather risk senior manager for our long range team. And we will be delivering this webinar here for the next 60 minutes. And our agenda is as follows. We're going to go over what happened last year to give us kind of a baseline as to what might happen this year, and at least we can compare the two. And then we'll go over the expected seasonal influences, and we'll take a look at some model guidance in terms of their tropical parameter forecast, and then we'll wrap that up into a tropical season outlook. And I'll pass it over to Steve, and he'll run us through what the summer is going to look like. May through September, we'll give a monthly outlook, and we'll throw some cooling degree days in there for good measure. And then after that, we'll go over the industry impacts from 4 different industries below, and then we'll take questions and answers with the time that we'll have left towards the end. So let's go over to the tropical season review. And taking a look at last year, it was kind of a busy season. It had 20 named storms, 7 hurricanes, and 3 major hurricanes, which are defined as Category 3 storms or higher. And we had 3 U.S. storm landfalls, one of which was a hurricane. We had over $4.19 billion in damage, so that part was relatively subdued, mostly because of where the storms came on shore. We went through our second straight year where no storms formed prior to the June 1st, at least the way things used to be, the traditional start of the hurricane season. We did have Tropical Storm 1 that formed on 1/16, and that was designated a subtropical system sometime later. If you note, there were a lot of storms that were out to sea and kind of recurved out into the open ocean. So let's take a look at the history of named storms and hurricanes by year. And each year you see 3 bars, the top of which is green, which is the named storms. And the next one is yellow, which is hurricanes. And the bottom one is a reddish color, which is major hurricanes. And the lines you see are the 10-year running averages. So you can kind of get an idea how things have gone. There were a couple absurdly busy seasons, 2005 and 2020, that stand out like a sore thumb here. So a couple things you notice about this. First of all, you don't notice an increasing trend in hurricanes or major hurricanes. A little bit cyclic in nature for sure, but it is no more or less than it was back in the 1950s. But what we do notice is there is an increase in the number of named storms. A couple reasons behind that. Number one is that we're better able to see these storms using the modern technology, satellite imagery, and there's a lot more eyes looking at them. So we can see some of the weaker storms that were probably there back in the day, but we weren't able to notice them. And the other thing is that the Atlantic Ocean in the tropics has been a lot warmer than normal for the past 30 years overall, and that in itself can give you more storm activity. So a slight increase probably from that, and then more so from being able to see the storms. So let's take a look at some individual storms. The first one that showed up, Tropical Storm Harold, from August 21st to the 23rd, and that came onshore at Padre Island, Texas. It was a stronger tropical storm, 60-mile-per-hour sustained winds, so below the hurricane threshold. Not much damage with that because where it came onshore, not a ton of population and infrastructure, but did have 1 drowning fatality as the remnants got into the desert southwest. So actually, the only associated fatality was in Las Vegas, of all places. And 6.98 inches of rain fell in Orange Grove, Texas, and we had winds that gusted to 67 miles per hour at the peak in Loyola Beach. So you see the remnants, you can trace it all the way through the desert Southwest up to the Four Corners region and then out into Kansas and Nebraska into the western Ohio Valley. So they definitely put some at least 1 to 3 inch rainfall amounts with some locally higher amounts in those areas. So impacts from this system were observed long after it came on shore. Hurricane Idalia was our highlight of the season, August 26 to August 31. It had maximum winds of 130 miles per hour, so it was a very strong major category 3 or 4 impact. Came on shore at Keaton Beach, Florida, just right at the bend of Florida. We had $3.6 billion in damage from this one. So this was the one that gave us most of our damage. It had 8 direct fatalities, and it left behind a lot of rain as it came inland through South Georgia and eastern sections of the Carolinas. 13.55 inches of rain fell in Holly Hill, South Carolina, and we had a storm surge level that was over 8.9 feet near Cedar Key, Florida, so highly impactful. And 5 to 10 inches of widespread rain from the eastern Florida panhandle to southeastern North Carolina, away from that maximum. And the other thing it did was produced a bunch of tornadoes across portions of Florida, Georgia, and the eastern Carolinas. And we had Ophelia, which was almost a hurricane, but not quite. 70-mile-per-hour sustained winds, so just below the threshold. This was in late September, and it came on shore in Emerald Isle, North Carolina, right in the central part of the coast. And $450 million in damage, no fatalities from that. 9.5 inches of rain in Greenville, North Carolina, 7.47 in Beach Haven, New Jersey, well after it came inland. Winds did gust around 83 miles per hour at the peak near Wrightsville Beach, North Carolina. This one you can see by the map, when it came on shore, kind of slowed down. So it had a pretty big rainfall footprint across the eastern Carolinas and the mid-Atlantic coastal areas. And parts of New Jersey got quite a bit of rain, especially just inland from the coast. Let's take a look at U.S. hurricane landfall trends. This is from a research paper that was put out. It is linked below and updated through 2020. So if we take a look at U.S. landfalling hurricanes from 1900 to 2020, you know, on the left side there comes up, there's lots of ups and downs, but there's a overall slight lowering trend since then. So despite all that has occurred with all the warming and everything that you hear about, we've actually had less landfalling hurricanes than we used to. And the major hurricane landfalls are pretty much right in line with the same trend. Comes and goes. We had a record stretch from late 2005 to early August 2017 where 0 major hurricanes made landfall. So that kind of contributed to the downward trend. And landfall trends will break it down by decade since the 1850s. And our largest decade is actually 1880. So we haven't had a decade like it since. And that kind of contributing to the lowering trend, if you will. But notice here we had spikes in the 1880s, 1940s, and the 2000s. And I have the AMO index, the Atlantic Multi-Decadal Index. And basically what that means is a measure of the warmth of the Atlantic Ocean. And notice here, and that big spike on the left side, that is around the 1880s. So that would explain that. And another one in the 40s and 50s. So it was a little bit busier there. And now we're in a busier period overall. 2000s, it popped up a little bit. And then 2010s were a little bit subdued despite the warmth. And then during the cooler AMO periods in the 60s and 70s, no, things popped. It came down a little bit. And then in the 20s, the same idea. And the AMO kind of makes a difference because if you look at the research on the right, you have more hurricane landfalls when you have a positive AMO versus a negative or a cooler AMO. And it doesn't really make a ton of difference on the Gulf Coast, to be honest with you, but it does make more of a difference along the U.S. East Coast. So you almost have double the risk when the AMO is positive. So you have about an average of 17.6 landfalls per decade. And another thing that hurricanes like to do is spawn tornadoes. And tornadoes often do occur along the path of tropical cyclones or even in some of the outer rain bands that get going. And map on the left shows all the tornado reports, at least up till 2007. And Notice it's a lot of them near the coast, but also well inland. You can see some reports in Oklahoma, Missouri, Ohio. So just because you're far away from the coast doesn't mean you can't be impacted by something when it comes to tropical systems. And tornadoes that are spawned by tropical cyclones account for roughly 6% of all reported U.S. tornadoes. So it's not an insignificant number. And they can also occur with even weak remnants well beyond the landfall point. So just because it's weak doesn't mean it can't impact you. And then rain is obviously a big impact with tropical cyclones. And what you see is the highest rainfall in each state in the lower 48 that is associated with a tropical cyclone. And there's some pretty big numbers, even pretty far inland. And if you take a look at Iowa, 9.0803 inches, Illinois, 10.2. And of course, you have your standard bearer of Harvey, 2017 in Texas, 60.58. That was obviously quite devastating. And Florida, 45.2. So the larger totals are more likely closer to the coast. But even as you go inland, some of these numbers, take a look at any one of them: 5 inches in Minnesota, 6 in Michigan, 15 in New York. If you get that kind of rain in a short amount of time, flooding and major impacts are definitely possible. So, important historical factors. The U.S. experienced a period of fewer landfalling hurricanes during the past decade, of 2010s especially, compared to the last 150 years. And we had 0 major hurricanes occur between October 2005 and early August 2017. And that was a record span that since we have been taking observations. 8 have occurred since then, though. So it's starting to pick up towards historical distributions at least a little bit. Impacts from a storm of sufficient intensity located in exactly the wrong place have shown that disruptions can be quite extreme. And high-profile examples of those, of course, are Sandy and Harvey. As landfall's intensities continue to match up with the historical distributions, cost will be greater because we have growth and exposure and property, wealth, and vulnerability. So we're putting more stuff in the way of these hurricanes right along the coast. So the odds are that odds are getting greater that any system will be able to hit something, and everything is becoming more expensive, so it costs more to fix. So tropical systems will become more and more impactful, even if the intensities do not. A landfall in areas of dense population and infrastructure increases the threat of widespread property damage and loss of life. And to make the matters worse, some evidence for a recent trend of storms to slow or even stall out near the North American coastal areas upon landfall. And that can lead to higher rainfall totals in the spots that get hit the most. So with all that in mind, let's fast forward into what will happen as opposed to what has happened. And as always, let's start with how we get tropical systems. Tropical development is enhanced when you have warm ocean temperatures. So think of that as more fuel to feed the storms. Now, vertical wind shear, we talk a bit about that. And that's basically a change of wind with height. So what you want is the winds to be blowing at the same speed and from the same direction from the surface all the way up through the jet stream level. That's when you have that happening, that's when storms are most likely. And the opposite, if you have winds that blow different directions or different speeds, that tends to disorganize the systems quite a bit. And we have large scale rising air motion near the storms. That also helps because any kind of help lifting is only going to make storms more organized. So let's take a look at some favorable hurricane season conditions in what we call the main development region, or the MDR, as going forward. And it's highlighted from just off the African coast all the way through the Caribbean Sea. And of course, the conditions we just talked about, if they're present in there, and things are going to be favorable. But the other thing that we want some stronger, wetter African monsoon conditions, because those can spit out tropical waves that go across. So if you take more tropical waves and you put them across the favorable conditions over the MDR, chances are you're going to get more storms. So the main seasonal drivers, we have El Nino in place right now, but the weakening of El Nino is in progress, and it will switch quickly to La Nina sometime during the summer. And by the time we get to the peak part of the season, August through October, we should have La Nina firmly established, and the NMME forecast for sea surface temperature anomalies on the right from August through October demonstrates that very well. See those blues just west of South America along the equator? That is indicative of a La Nina. And then other things we look at, now the AMO, we talked about that earlier, and all those orange colors across the Atlantic, that is a very aggressive forecast for above average water temperatures. So we're looking for years like that. And the PDO, the Pacific Decadal Oscillation, note how much warmth there is in the North Pacific, but more of that warmth is located away from the US West Coast. So that is indicative of the negative phase of the PDO. So we're looking for years that had these three things in common, and this can kind of give us a clue as to what kind of season is coming up. Let's just focus on ENSO for just a moment. And what you see here are forecasts from modeling centers all across the world for water temperatures in the equatorial Pacific. And we get to a minus 0.5 degrees Celsius anomaly. It is indicative of a La Nina. Well, right now, we are on the cusp of getting to neutral. And probably in the next few weeks, we'll be in the ENSO neutral stage. And then if you watch that maroon line, that's the model average, that it decreases. And then by the time we get towards this middle or latter part of the summer, the 3-month average is below the threshold of La Nina. And then, of course, it goes further from there into the fall. So every single model here, except for maybe one, shows a steady cooling trend. Now, some models are more aggressive than others. And we kind of lean it towards the cooler end a little bit with our forecast, maybe towards the blue line. That would be a little bit more realistic. But in any event, La Nina is highly likely during the course of the tropical season, and that's going to mean something. Because if we look at how ENSO impacts tropical systems, there's a lot of stats here, but I want to call out the differences between all El Nino since 1995 and then the neutral and then the La Nina. So and notice here 13 named storms on average versus 16 for neutral and 17 for La Nina. So neutral and La Nina are favorable states for tropical development in the Atlantic Basin. And that doesn't just go for storms, it goes for hurricanes and major hurricanes. And what we have are the minimum and maximum number of storms that have developed under these conditions. So obviously there is some spread. So for example, neutral ENSO since 1995, eight happened one of the years, and then 28 happened another year. So there's some variability in there. So other things matter, but once you have this setup, things tend to be more active. So let's take a look at some analogs. And our analog average now, our 30-year average regardless of ENSO state, 14 named storms, 7 hurricanes, 3 major hurricanes at 1991 to 2020, 30-year average. Now, if we take the 1995 plus La Nina years, that increases to 17.4, 8.8, and 3.9. And then if we take a look at the analog years that we picked, based on those ocean temperatures before, it is even higher, 20.9, 10.7, and 5.0. That's very aggressive from the analogs. And here's some top analog years, 2010, 05, 2020, 2016, 98, 07. There's some heavy hitters in this group, especially the second two, 05 and 2020. And note, a lot of these years have active activity in the Gulf of Mexico and places near Florida, especially 05 and 2020. So analog years, you take a look at them, do show a potentially very active season. The other thing it shows is at least the potential for a lot of recurving storms too. So not every storm that shows up on the map is going to necessarily be an impact, but this is to tell you that there is a lot of potential with this season closer to the U.S. coastline. And taking a look at this a different way, we take our analogs and we break them down towards track density anomalies. So we have these oranges and yellows. That's where more of the systems went versus normal versus our 30-year average. And a lot of areas are lit up, which you might expect with a busy season, but the Western Caribbean and the Gulf of Mexico are probably lit up a little bit more. And then you notice a bit of a reduction in activity across New England, especially through the Canadian Maritimes. So the analogs do not quite favor as much as other areas to the south. And it also shows a couple of recurving tracks. You can almost draw an arrow from east of the Lesser Antilles or east of Bermuda, and then another one way out east, was west of the Cabo Verde Islands, and then up towards actually Spain and Portugal. So a couple things to keep in mind there. And if we break it down by month, August, there's a significant storm recurving track there. So maybe getting off to maybe a little bit of a slower start when it comes to getting storms near the coast. Although the Gulf of Mexico is highlighted a little bit, but the Caribbean is not. So maybe slightly slow getting going there, at least potentially. But if we go to September, notice everything starts shifting to the west. It's a little bit more active, even through the Caribbean and along the East Coast and Gulf Coast. A lot more of those oranges there. And then in October, the Western Caribbean through the Gulf of Mexico, great potential for above average activity, but a little bit less of a recurving risk. And that makes sense because most of the time the MDR season tends to wind down during that time, and we get storm origination in the Caribbean or the Gulf of Mexico itself. And then rapid intensification, that's something that's come into mind in recent years. All the warm water temperatures, we've seen some of these storms go from weak to Category 5 in a very short period of time. And so we took a look at potential for rapid intensification through our analogs, and you note that the Caribbean and the Gulf of Mexico have the best chance for this type of thing to occur. So just because the storms are going to be plodding along through the MDR and before they reach the Caribbean doesn't necessarily mean they won't strengthen suddenly. So what this tells us is that we're going to have to keep a very close eye on that potential as storms get into the Gulf of Mexico and the Caribbean. Current sea surface temperatures don't look exactly the part just yet because our La Nina hasn't formed. Note, there's still a lot of warm water in the tropical Pacific. But if you look at the area right up against the South American coast, you start to see some cooler water starting to poke through. And that's going to kind of spread westward as we go through the spring and into the summer season. And note all that warm water in the tropical Pacific and the MDR getting up into the Gulf of Mexico, that's only going to get warmer, especially the Caribbean and the Gulf of Mexico. So we're set up pretty well for an active season in terms of water temperatures. Taking a look at some tropical parameters. The sea surface temperature forecast, we'll harp on that again. The CFS does also show a very warm look to the sea surface temperatures in the MDR through the Gulf of Mexico. But the other thing it shows that we haven't talked about yet is shear. If we take a look at the forecast for the peak part of the season, there's a lot of blue located across the Caribbean, the southern Gulf of Mexico, and the MDR. And that's indicative of below average wind shear. And we talked about that earlier. That means that it's a very active or very favorable pattern for an active season. So both of these signals strongly suggest an active tropical season is coming. Take a look at the ECMWF rainfall forecast for the peak season, August through October, and look at all that green from the southeast coast to the Gulf of Mexico and into the Caribbean. So it's a very ominous signal for high levels of activity across the tropics. It's hard to get away from that. And the ECMWF named storms forecast. Now, what I did here is put in some of the verification from the ECMWF site, and what you see is these blues is the forecast from this month each year for the number of tropical systems that will occur. And the thing in the dotted red line is what actually happened. So the thing that stands out right now is that right now the ECMWF is forecasting more named storms than it has since 1993. But the other thing that kind of stands out is that the ECMWF failed to catch the 3 biggest years. It didn't really forecast a lot of storms as a result of that. So this in itself doesn't necessarily mean a big year is coming, but it is it's certainly enough to give you some pause because the three biggest years that actually forecast too many storms. So that is something to watch, but the fact that it's going for so many, it's very alarming. So I'll summarize the environment. A developing La Nina is favorable for tropical development. Analog years indicate well above average tropical activity can be anticipated. Some big hitters like 05 and 2020 are very high on the analog year list. Warm ocean temperatures are anticipated for the heart of the hurricane season, which are favorable conditions for development. And wind shear is forecast to be below normal by all guidance, and that is also favorable for development. Model guidance strongly suggests above normal rainfall across most of the tropics, which is a good indicator and an ominous signal. Rapid intensification of storms is favored by our analogs, and these signals strongly suggest that a very active season could unfold this year. So let's take a look at where these storms might go. And the upper level patterns can kind of give us some clues. And first of all, let's take a look at what happened during that record low landfall period. So 500 millibar anomalies can kind of give us a clue as to what happened. And note the big high pressure in the middle of the Atlantic and another one in eastern Canada up towards Greenland. And then we had a low pressure area right along the eastern seaboard. So we had a trough along the east coast. And think of that as like a brick wall that storms won't be able to get through. So what the storms did is they'll go south of the high, and then the low pressure system will pick them up. They will pass in between and go out to sea. And every single hurricane track that occurred from 06 to 16 is plotted here. Look how many storms were coming westward and then were drawn northward and then out to sea. Now, of course, a few got through here and there, weaker storms. So the Gulf of Mexico had a few hits. Of course, the East Coast did too, but there weren't all that many. And more often than not, these storms were able to recurve and become a little bit more harmless. Let's compare that to 2020, where everything went pretty active. And notice some differences. That trough is actually retracted back into the central part of the country, and a big area of high pressure set up from the Canadian Maritimes through the eastern seaboard. And that high kind of acted as a block. So the high is actually a little bit further west than it usually is. So every time these storms were able to come westward, they were drawn up north by the trough and then into the Gulf of Mexico. Note here all the hurricane tracks in 2020. Now it's this 1 year, so it doesn't look as active as the other plot. But notice how many of these storms were able to get closer to the east coast, and look how few were able to recurve. So high pressure in the Western Atlantic definitely steered more storms in the direction of the Gulf of Mexico that year. Our 2024 analog average from July through October reveals a few other clues. First things first, we have a big area of high pressure across central and eastern part of the country and another one in the middle of the Atlantic. A little bit of a weakness in between that you'll notice. And then instead of high pressure across the Canadian Maritimes, we have low pressure. So this means a couple of things. Storms that are able to get underneath will have no trouble getting into the Gulf of Mexico, and we'll have a little bit more of an enhanced threat across Central America and into mainland Mexico as well. And then the secondary track will be some recurving systems. So being able to sneak between the low and high pressure systems. And then the other thing that with the low pressure near the Canadian Maritimes is that the storms that do recurve northward will probably be safely guided out to sea, at least most of them. So this would imply that the northeastern part of the country and the Canadian Maritimes would be a little bit safer. But if it's going to be a very active season, that doesn't necessarily mean you're out of the woods. You still should be on high alert. So let's wrap this up into an outlook. We're going to go for 25 named storms, 12 hurricanes, and 5 major hurricanes, which, if verified, would be one of the more active seasons on record. And we're going to favor the southeast coast and the Gulf of Mexico, and of course, Central America and the Caribbean areas for the areas most likely to have a storm pass nearby. The Northeast is not highlighted, but you still have to keep a pretty close eye on things because remnants can get up there, and of course, exceptions to the rule of the seasonal tracks can occur, and you might get a rogue storm that sneaks up there. So even though you're not highlighted, you're not out of the woods, especially in a potentially busy year like this. So here's our list of Atlantic storm names, and we expect to use a few of them this time around, from Alberto to William, and then we have a supplemental list that we'll definitely have to dust off. At least have it ready to go because there's a higher than normal risk of breaking into that category. So let's wrap this up before I pass it over to Steve. Almost every pattern indicator is favorable for tropical development. The DTN forecast will be one of the most active seasons on record if it verified, and there is a risk that it could be right up there. Analog patterns suggest that there is a higher risk of landfalling storms, especially across the Gulf of Mexico and the southeast US. Analog patterns also suggest an increased risk of rapid intensification of individual storms. Not everyone will do that, but one or two of them out there could be pretty intense. Storms may develop before the June 1st start of the season, and storm development is probably going to linger into November and December this year. The analog years definitely suggested that as well. Even though the Northeast is not necessarily favored, the sheer number of storms in the forecast should keep the region on high alert anyway. Even a weaker tropical system can have significant impacts if it strikes a highly vulnerable location. And also, this isn't locked in. There are some things that could cause this to fail. And we'll talk about this probably a little bit later, but there are some things, there's no guarantee that it's going to be gloom and doom. There are things that can make this not as robust as we think, but all the signals are that this year could be very anomalous. And with that, let me pass it over to our fearless leader, Steve Strum, and he'll talk about the summer.
Thank you very much, Nate, for walking us through the outlook for the hurricane season. Now we'll kind of take a look at the overall weather patterns expected for North America. So starting off with the temperature outlook for the US and Southern Canada, you can see a lot of red on all the maps there. So both on the summer composite as well as the May, June, July, August, and September monthly maps. There's variation month to month in terms of where the most anomalous heat will likely be. But in the end, most of the country is looking to see a hotter than normal summer. But overall, the Rockies, Southwest, and Plains should be seeing temperatures more anomalous the majority of the time, whereas the East and West coasts will see more variability. And so those areas will average warmer than normal as well, but not quite as extreme as the Rockies and Plains region of the country is expected to be. Note that on the West Coast, as well as across the Northeast, temperatures there not expected to be as hot during June, but then those areas could see a higher risk for more anomalous heat as we head to the end of the summer by August. At the same time, the southeastern US may see less anomalous heat as we progress through the summer season. So starting off warmer through midsummer, then possibly temperatures easing back at least a little closer to average by August. But a lot of that will depend on tropical activity. And so if we do see a lot of rainfall from tropical systems, during the second half of the summer season, that would tend to suppress temperatures. And on the other hand, if we, are lucky and we avoid all the tropical impacts across the Gulf Coast areas, likely it will end up hotter than what is currently forecast. Now, looking at the rainfall outlook, again, a lot of the southeastern quadrant of the country is pretty much going to be determined by tropical activity. So we have areas there from Texas to the eastward along the Gulf Coast highlighted to be wetter than average in July and August. A lot of that, again, is going to be the likelihood of having tropical impacts across that part of the country. But in reality, the way it's going to work out is that there's going to be swaths within that region that see very anomalous rainfall, and then other areas in between that just happen to manage to miss out on all the tropical systems and potentially even end up drier than average. So expect a lot of variability along that Gulf Coast area, not just everyone being wetter than average, but obviously all the areas that see a tropical storm will be likely wetter than average. Otherwise, though, we should see a persistent drier than average pattern across the Rockies, the Southwest, as well as up into the Northern Plains area. The big factor there is that with the developing La Nina, we should see less overall monsoonal rainfall across the Southwest and the Rockies. And so typically that region of the country sees a lot of daytime, evening thunderstorms that develop in July and August as we see more moisture come up from both the Eastern Pacific as well as some from the Gulf of Mexico into that area. And so the combination of that typically leads to that afternoon thunderstorm activity. But with the La Nina, that typically is suppressed. And so as a result, those areas are likely going to end up drier than average. Now, if you look at the temperatures from a cooling degree day standpoint, you can see the overall trends for the last 40 years on the left-hand side in terms of the year-by-year totals for May to September, as well as a ranking on the bottom portion there. And you can see the darker orange bar is 2024, our forecast for this summer, and currently expected to be the third hottest summer on record, or at least the last 40 years, which is about the same thing for the US. And so definitely a very anomalous summer expected. But one thing to keep in mind is that we are still forecasting the most anomalous heat to be across the Rockies and Plains, which is also the least populated area of the country, at least relative to the coastal areas. And so if for whatever reason the pattern did end up shifting farther east than what's currently expected to where the core of the anomalous heat was, more towards, say, the Mississippi Valley instead of the Rockies and Plains, that would put more of the stronger warm anomalies in play for the bigger cities across the eastern half of the country, and then pump up our cooling degree day totals even a little bit higher than what are currently expected. On the other hand, if we do see a lot more rainfall across the eastern half of the country, whether it be from tropical systems or just in general, that would tend to suppress the temperatures more on an absolute basis. And so we would tend to see fewer cooling degree days, still higher than last year, but potentially not, third highest, of the last 40 years. On the other hand, though, if that does happen, we would be seeing much more humidity. And so the trade-off will be whether we see higher humidity and higher heat indices or just higher absolute temperatures. So either way, it should be a hot summer. The question will be just the exact mode, and that will just depend mostly on rainfall across the eastern US, which will be in part driven by tropical activity. Now, drought conditions are currently ongoing across the Southwest as well as portions of the central US, but we are entering the wettest period of the year across the central US. Typically, May is the banner month for rainfall because of all the thunderstorms across a lot of the central US. And so we do expect a lot of that drought in the plains and up towards the upper Midwest to erode during the next 6 to 8 weeks. And so conditions there should, at least for a while, improve relative to what we have now. On the other hand, we're already out of the winter wet season across the Southwest, and we are expecting a drier than average pattern there for the summer season. So drought will likely expand across the Southwest and the Rockies in general as we progress through not just the next few months, but likely all the way through into the early part of the fall season. So definitely expansion of drought across the interior West will be something to watch as we progress forward through the summer season. Now, that will in turn influence the wildfire outlook. Obviously, we're about through with April already, but looking at May, June, and July, you note that there is a general trend towards enhanced wildfire risk across portions of the Southwest. And then in July, you start to see that kind of shift up into the Great Basin area, Northern Rockies region. And this only goes out through July, but you would expect August and September and October to see further expansion of the wildfire risk area across the interior West because of the expected dry and hot conditions. Note also those green areas in California indicating reduced wildfire risk. That's because of the second consecutive wetter than average winter season across California. So moisture is in good supply across California this year. And so wildfire risks are going to be lower than they have been in recent years. Now, turning to severe weather, it's been a pretty average year so far in terms of severe weather. You can see all the individual severe weather reports on the left-hand side, and then just year-to-date totals of tornadoes on the right-hand side in that red line, which you can compare to not just average in the black line, but recent years as well. And so we're running just below average in terms of tornado counts, but we are going to be seeing the overall pattern in the next few days actually trend more active in terms of severe weather. And again, we're heading into May, which is the most active month of the year for severe weather anyway. And so we are likely going to be seeing an overall uptick in severe weather activity as we progress forward here for the next several weeks. And so again, we should stay at least average in terms of severe weather, and we may at times reach above average in terms of our severe weather totals based on the pattern that we have coming up here in the coming weeks. So definitely just getting going here into the heart of the severe weather season. Typically now through the middle of June is when we have our greatest levels of activity, and then things kind of taper off as most of the activity shifts farther north into the northern US and up into Canada during the course of the summer. So just looking at tornadoes and wind reports in general, we have had a few tornadoes across the western US with some of those winter storms, mostly though across areas of the central and eastern US. Note the kind of the two maximums across the Ohio Valley area as well as along the Gulf Coast, where we've seen the bulk of the severe weather so far. And there's been very little across the northern tier of the country, but that will be changing. And in fact, the pattern going forward will become more favorable than usual for severe weather across the northern tier from the Dakotas eastward across the Great Lakes into the interior Northeast. So while you don't see a lot of dots in those areas right now, that should change quite a bit as we go forward through the next couple of months. And here, part of the reason why you can look at this outlook for expected jet stream winds for the upcoming summer season. So those yellow, oranges, and reds indicate areas with higher wind speeds than usual aloft, and that's kind of an indication of where the jet stream will be going this summer season. The blue areas indicate weaker overall upper level winds. But typically, you tend to see the most severe weather kind of on the south side of that jet stream. And so that northern border area of the US could be much more active than usual this summer season, with the overall jet stream itself being farther north than typical this year as a result of the expansive heat dome that is expected to be in place across the US. Also, that area of weaker winds across the southeast, the Gulf Coast, down into the Caribbean is an indication of that lower wind shear that will also be in place for those areas, which will, of course, be promoting tropical development as well as we progress through the summer season. Now, looking at those thunderstorm risks in a month-by-month basis here, the yellow, oranges, and reds indicate the areas of higher thunderstorm risk and potential on a monthly basis. And so again, note that a lot of that is across the northern US over the next several months. The south central US, Oklahoma, Texas, those areas in there are in blue in May, indicating less risk, but May is the most active severe weather month in that part of the country. And that blue might be a little bit overdone, but either way, even average to somewhat below average severe weather risk in that area is still a lot of severe weather typically. So don't expect that we're going to be seeing no tornadoes or just very quiet conditions across the south central US for May. There will still be severe weather outbreaks in that part of the country as we go forward in May. But again, the point here, though, is that the northern half of the country could be seeing above average severe weather potential here for really the bulk of the summer season. Now, kind of summing up the overall forecast here, starting off with the West Coast, the main pattern there will be one of relatively seasonal weather at the start of the summer season, but generally trending more anomalously warm as the summer season progresses, but overall still not as hot relative to normal as areas farther inland. Now, across the Great Basin, the Rockies, the Southwest, those areas will be quite hot this summer and drier than average with less monsoonal rainfall than typical. And so that will lead to an expansion of drought as the summer season progresses. And that will then in turn lead to a higher than average wildfire risk for all of those areas, especially as we run into the end of the summer season and then right on through the early part of the fall season. So that will be an area to watch for higher fire risk this summer season. Farther east across the central US, again, everyone running above average, so widespread higher than normal temperatures. The highest risk for the more anomalous heat will be across the latter part of the summer season across the northern areas, whereas the southern areas will see the higher, more anomalous heat risks in the early part of the summer. So more anomalous heat in June across the south, more anomalous heat by August across the northern US. But either way, all areas staying hotter than normal throughout the summer season. For the East Coast areas, the Southeast and Northeast, again, the more anomalous heat in those areas coming, at least across the Northeast, late in the summer season. The Southeast, so we'll see, again, kind of a variation depending on the amount of rainfall we see. We could actually see less heat there by August if we do see more rainfall from tropical activity, which would tend to suppress the temperatures on an absolute basis, but then bring more moisture, more humidity, and potentially higher heat indices. If it does turn out that, again, we don't see as much tropical activity as expected, those areas likely would end up hotter than currently forecast, just because of the reduced rainfall and drier soil conditions. So in general, again, everyone running hotter than normal, but the most intense heat across the plains and the Rockies. Looking at renewable energy here for the summer season, anomalous sun, basically more sun than average across the areas of the Rockies and north central US, as well as across parts of the mid-Atlantic and Northeast. Obviously, the south central US, Oklahoma, Texas, the southern Mississippi Valley, those areas tend to be very sunny during the course of the summer season. And so while it is near average, those areas will tend to be kind of bimodal. Obviously, anytime we have a tropical system move through the area, there's going to be a period of lots of clouds and rain and unsettled weather. But then the remainder of the summer season is likely going to be, for the most part, at or above average levels of sunshine in those areas. So keep in mind that normal is a lot of sun across the south central US. And so even though it's not forecast to really be differing far from normal, it likely will again be limited mostly to a lot of clouds with the tropical systems and otherwise, for the most part, staying persistently sunnier than average. But for the most part, you can see across most of the country with the heat, typically that is coming with a lot more sun than usual as well. Now, in terms of windfall or wind speeds across the country, typically, again, the south central, southeastern US is going to be varying mostly based on tropical activity. So we're not really forecasting anything anomalous there at the moment. But again, there's going to be swaths with a lot more wind wherever tropical systems tend to move, and so that will impact the monthly averages. But excluding tropical activity, near average winds for the Gulf Coast. And so for the most part, areas from the Central Plains up through the Rockies could be seeing slightly elevated winds relative to normal. There's a slightly higher probability that the Ohio Valley could be seeing less wind than average. We're not showing it in the actual forecast, but the probability map does show that heightened risk for less wind than average. If we do see the main area of high pressure kind of settle into that region during the second half of the summer season, that would tend to promote less wind overall than average across the Ohio Valley. So we'll have to watch that and see if we do see a reduction in wind generation during the second half of the summer season across the eastern US. So key messages for this summer. Again, one of the hottest summers on record currently forecast, the strongest heat forecast across the interior West as well as the Plains region. The East Coast, though, will likely see a trend towards more heat during the second half of the summer season, at least across the Northeast. The Southeast, again, may see less heat late in the summer if we do see a lot of tropical activity and more rainfall. Drought and wildfire risks will be the greatest across the interior West, so Southwest Rockies, Great Basin areas. And so we'll have to watch the increasing risk for wildfires as the summer progresses. On the other hand, areas across the upper Midwest and Great Lakes will be likely seeing a lot of thunderstorm activity this summer season, more so than usual. And so less drought risk there, but more risk for severe thunderstorm impacts in those areas. Obviously, we mentioned the wind and solar here just a minute ago. Areas across the Rockies and parts of the Central Plains potentially seeing more wind than average this summer. And most of the interior West and northern US also seeing more sun than average as we progress through the summer season. So looking at some individual industries here, starting off with utilities, we are again going to have the biggest impact coming from temperatures with the widespread heat currently forecast. So above average energy demand across the entire country this summer season, but the strongest, most anomalous demand, at least relative to normal, is going to be across the central and interior Western US, with the East Coast having a higher demand coming in across the Northeast by late in the summer season. Severe storm risk will be impacting utilities during the or across the northern half of the country most anomalously. So above average wind events, above average hail events, above average tornado totals across those areas expected as we progress through the summer season. So outages also likely being higher than average, at least from storm-related outages in those areas. The southern US may see a reduction in severe weather in terms of regular thunderstorm activity, but you're going to see a increase from tropical activity. And so as a result, outages from tropical systems, either from winds or flooding and those type of events will be certainly a high risk for those areas during the summer. But again, since the hurricane season doesn't really peak until August, September, and October, the risk for those type of tropical impacts will be skewed towards the second half of the summer season. And certainly the hot, dry conditions across the West will be also accompanied by a lot of sun. And so above average solar generation expected in those areas, along with higher wind than average. And so that may help to offset the higher demand in those areas somewhat. Aviation impacts with the jet stream being farther north than expected in southern Canada relative to where it typically is. You will be seeing, for the most part, weaker upper level winds across the southern US, so not really a lot of impact on flight times, but northern areas will be seeing some greater impacts on differences in flight times between east and west traveling flights. With the severe weather in those areas as well, likely some impacts on airports like Chicago, Minneapolis, Detroit, even up into interior areas of the Northeast in terms of more impacts than usual from severe thunderstorm events causing some periodic delays. Obviously, with that will come more turbulence events as well. So northern half of the country in general, we could be seeing more turbulence than typical this time or with this season. So that will be something that may at times cause some rerouting of flights and that kind of thing as well. Now, obviously, the public safety side will be very, very strongly influenced by the widespread heat. Also, a lot of humidity across the eastern U.S. this year. And so as a result, the high heat indices, the high wet bulb globe temperatures will be impacting a lot of outdoor sporting events, just events in general, outdoor concerts, that kind of thing. And so that will be an ongoing threat throughout the summer season, just those higher temperatures. Obviously, the bigger risk for outdoor events from thunderstorms will be across the northern half of the central and eastern U.S. this year, as that area will be the greatest focus for thunderstorm activities. But across the south, the trade-off there will be that you'll trade off regular thunderstorm activity for increased tropical risks. So as we just mentioned earlier, landfalling storms will bring all sorts of potential hazards, either from tropical storm related winds and rains and flooding, or just the thunderstorms and tornadoes that come with those tropical systems as well. So definitely a lot of potential disruptions. Again, that risk across the southeast will be higher as we head towards August and September, and less so early in the summer season. And finally here, looking at some offshore impacts, obviously with the higher than usual threat across the Gulf this year, and that being kind of one of the main focus areas for tropical activity, there's going to be a lot of impacts in terms of shipping across the Gulf of Mexico, either in terms of getting through the region or getting into or out of ports because of all the potential periods of higher than average winds and waves across the Gulf of Mexico. Obviously, onshore impacts will be significant as well. So either at ports or onshore refineries, that kind of thing. We'll be seeing periodic impacts in places from the tropical activity. Disruptions to LNG shipments will likely be the case. Obviously, shut-ins on offshore oil and gas, definitely something to watch at times as well. But we've kind of entered into this period now where oftentimes the reduction in demand from tropical activity outweighs the loss of supply, in terms of loss of production in the Gulf. And we do have a tropical system. And so we could be seeing multiple tropical systems make landfall across the Gulf Coast this year. And so as a result, we could see a lot of periods with greatly reduced demand because of all the clouds and rains and power outages that we'll see with those tropical systems. And so even though we are going to be seeing periods of reduced production in the Gulf of Mexico because of those storms, there's also going to be a lot of periods where we do see reduced demand across the Gulf Coast because of all the storm-related impacts. So to kind of summarize things here, again, a very active hurricane season, a very hot summer expected, and certainly a lot of potential impacts from tropical systems across the Gulf Coast, and a lot of thunderstorm impacts this year, and severe weather across the north central U.S. Great Lakes area. And so a lot going on this summer season. So Nate, what kind of questions have you seen come in so far? We can take as many as we can here in the next 8 or 9 minutes.
Thank you, Steve. Beautiful way to wrap up the presentation. A couple of questions have come in. If anybody has any additional questions that we can, please put them in the Q&A feature, even the chat feature, and we will round them up and answer as many questions as possible. And the first one to come in is, would the 2024 tracks seem to have activity going later in the year than average? I can take that one. The short answer is yes. A lot of the analog years that had this many storms had storms linger well into October and November, and even in some cases into December and early January. It's a little bit early to suggest that the impact is going to be quite that severe, but I would be on the lookout past the typical time in later October where things start to slow down a little bit. So November could be a little bit busier. December definitely could be a little bit busier, although that's not very busy on average. But we're going to have to keep our eyes open for a long time this year. This could be a very fatiguing type of season. Got a second question. Are there any comments regarding a dismal Pacific Northwest hydro season? In other words, what kind of precipitation do we expect in that particular region? Is it going to be very dry out there, or will it be, let's see a little bit more activity out there than usual?
Yeah, I can go ahead and take that one. Obviously, this past winter season, we had the greater, more anomalous rain and snow was in California and across the, Central Rockies and so forth. And so we saw reduced snowpack across the Pacific Northwest this year, which of course is going to lead to the reduced stream flows as we head through the next few months. And again, with the overall pattern being drier than average across a lot of the western U.S. as we head through the summer season, we're not going to see a lot of additional input of rainfall in those areas going forward, over the next several months. So yeah, it's not the greatest year up there for hydro, but on the other side, we have been seeing, obviously, with California and the Central Rockies being pretty wet this past year, we're seeing another year where we're seeing a lot of increase in reservoir levels across those areas. So better hydro, California, Southwest this year, but worse across the Northwest. But as we do turn into this La Nina here, we should see a flip in the script for next winter with better hydro across the Northwest and worse hydro across California next year. But obviously, we have to get through this year first.
Outstanding. Thank you, Steve. All right. I'll ask another question here. I hear a lot of gloom and doom about this season. What could go wrong that could make it less active than anticipated? I'll take that one. Well, a couple of things. Number one, there could be such an active season from African waves that develop early that you could kick up a lot of Saharan dust and spread it across the tropical Atlantic and even into the Caribbean and the Gulf of Mexico. And when you have a lot of dust in there, usually there's a drier layer within, and that tends to disrupt the organization of thunderstorms and tropical systems. So there is a chance, at least for a period, like where this could slow things down a little bit. That would be more of an impact in July, August, more than September and October, because you start to slow down those waves as we get towards the peak part of the season to a certain extent, and the jet starts to shift a little bit further south. So that'll take it out of the sand area a little bit. So that tends to slow down, but the early part of the season could be limited by that. Another thing that could happen is that we could have some disturbances that get down into the tropics that create some shear that we don't expect. And if that were to occur, that could slow things down a little bit here and there as well. And a third thing is if La Nina doesn't really develop too much at all and everything's on the warm end, if we don't weaken the El Nino fast enough, then that would probably provide a little bit wind shear as well. That's kind of a lower risk, but it's not a 0% chance either. So those are the types of things that we're looking for as we get into the subseasonal and closer to the actual storm season, getting into, as we get towards the tropical season. We'll be watching all that stuff. All right. Got one here. I think it's an interesting one. Are you expecting a better setup for severe multi-cell storms or supercells in the Midwest? I think I can take that one as well. I think at first you'll see a lot of activity, especially May to early June, where you'll have thunderstorms develop in a scattered nature, and then they'll kind of come together into a complex overnight and come into the Midwest to a certain extent. I think you'll see a lot of that from May into early June. But by the time we get into the later June into July and into August, and the jet stream winds shift a little bit north, then I think we'll see a lot more in the way of complexes. You'll see activity develop scattered in the afternoon and will quickly grow upscale into thunderstorm complexes. So I think those are the types of things we'll have to worry about, is watching these complexes rip through parts of the Great Lakes Midwest, sometime during the afternoon, sometimes during the overnight. So we'll have to be watching those types of things with the severe weather risk during the summer season. And I got another one here. How do you expect transitioning ENSO and warm North Pacific water temperatures to impact the weather trends? And we'll call it parts of the Midwest, but we can broaden the spectrum a little bit. Let's call it the central US. Will it matter if ENSO is closer to El Nino versus the expected La Nina?
I'll go ahead and answer that. There's also another question that I saw that popped up and asking about is the forecast of the rate of weakening of El Nino high reliability. Kind of I'll lump those together since that's kind of related, obviously. Yeah, I mean, certainly if we do see a slower transition to La Nina, that would, generally speaking, tend to reduce the risks for more intense heat across the central US. Basically, a faster transition to La Nina is typically going to result in more heat across a lot of the middle part of the country. We get a faster development of that typical summer heat ridge and a more persistent nature of it. And so that is one of the things that we'll be watching this summer season. Even if we don't transition to La Nina very quickly, we're still going to be higher than normal, but potentially we're not as hot as what's currently forecast. So we'll have to watch that. In terms of the reliability of the forecast of that transition and the weakening, that's certainly the biggest question, is the exact timing. There's very high confidence that we're going to see the La Nina go into a pretty quick demise here in the next month or two, just based on some upper level or just some wind patterns across the Atlantic that we'll be seeing the next month or so. Plus, there's already an expansive pool of below average water temperatures across the equatorial Pacific below the surface layers. And when we see another, disturbance or two that can kind of flip the winds around, we should see a lot of that upwell very quickly and cool the water temperatures quite dramatically and quickly. But exactly when that happens, whether it's, starting in the next couple of weeks or whether it takes another month or two before we fully get rid of El Nino is kind of the big thing. But either way, I think by the time we get through the second half of the summer season, we'll have La Nina in place. But the next month or two is more certainly uncertain. But that won't really have a huge impact on the outlook for the second half of the summer season in terms of the widespread heat expected in August, for example.
A great point, Steve. And with that, we have reached the top of the hour, so we'll have to conclude the webinar. I'm going to pass it back to Andrea so she can close the show for us.
Yeah, I will just mention that we will try to get all the other questions replied to as best as we can here later today.
Thank you. Thanks, Steve, and thanks, Nate, for a great presentation on our tropical outlook. For the first time, when you registered for today's webinar, you did have the option to register for the remainder of our webinars that we have scheduled for the remainder of 2024, sorry. So if you did not see that or not get it, don't worry. We will be sending out invites for our mid-season, which will take place in June. And then all the way in October will be our winter webinar. So take a look for those. Thank you and have a great rest of your day to everybody.